I'm so delighted today to be here with Dr. Michael Levin and with Jordan Hall. Michael Levin is a developmental and synthetic biologist at Tufts University, and Jordan Hall is a pioneer of disruptive technologies. And a person might say, why are we putting these two people together? But I was speaking at a conference this weekend, and I gave a talk about how art can be a translator key for other arenas. And a lady came running up to me afterwards and she said, "Oh my goodness, you helped me so much." And I thought, how could that kind of a talk be helpful to anybody? But she said, "You made me remember something from many, many years ago." She said, when I was younger, anytime I would go to a party, I would always ask the question, what is it that you've learned or that you do where you have gotten so familiar with it and that you found out that there is no bottom? And so I said, well, for you, what is that? And she said, milk. There's no bottom to milk. And when I discovered that, I decided to be a cheesemaker. And then I met a guy who was a hairdresser, and I asked him, and he said, hair, no bottom to hair. And then she said, I met a painter, and I thought he was like an artist, but no, he painted houses, and he said, paint, there's no bottom to paint. So what I take that to mean is that once you get into an arena and you get down to the deep truth of that arena, that allows you to have a lens that's going to help you to discover truth in other arenas. So that's why I'm putting you two together. So we had agreed on some topics, but before we get started on those topics, Mike, I was listening to a conversation that you had recently with Jason Bongard and Richard Watson, and one of them made the comment about Mike's bow tie stuff. So I thought maybe you could describe what that bow tie stuff is, because I think that's one of those deep truths that translates into a lot of other arenas.
Yeah. I think Josh was referring to a recent paper that I had in this journal called Entropy, talking about this fundamental. So I'll describe it first, how it works for cognitive systems, and then talk about what I think it means for development and for evolution. So one way to think about what cognitive agents do is that at any given moment in time, you don't have access to the past. What you have access to are the memory engrams that the past has left in your brain or body or some other medium that you're using. So that means that as a cognitive system, you're constantly undergoing the process of sense making and world construction. You at any given moment, you have these memory traces. You now have to figure out what they mean. What do they mean to you? So at the moment, you build a picture and continuously rebuild a picture of yourself and your world and your past and so on in a way that's adaptive at the moment. It doesn't have to be the same way you understood them before. And as a simple example, I'll just use this caterpillar to butterfly transition. So caterpillars have a brain suitable for crawling around. So they have this like two-dimensional, they live in this two-dimensional world basically, and they can be trained and they will have certain memories. And then they undergo a massive metamorphosis to be a butterfly. Now, a butterfly lives in three-dimensional world. It's a hard-bodied creature, not a soft-bodied creature. So the controller has to be completely different. And what they find is that they still remember the original training, despite the fact that that brain was basically completely refactored. So most of the cells were killed, taken, the connections were taken apart. All that was, redone, and yet the information stays. So for years, I used to wonder about what turned out to be the less important question, which is, where is the information and how do you hold on to information when the information medium is sort of torn up and redone? But the even more interesting question is around the idea that actually the specific memories of a caterpillar are of no use to the butterfly. The butterfly does not want the leaves that the caterpillar was eating. It doesn't move the way that the caterpillar does. Those exact memories are of no use. But what is of use is a reinterpretation of the deep lessons. A generalization. So instead of leaves, then food and things like that. So what you have, so this is the bow tie, right? So there's a couple of different ways to picture the bow tie. One way to picture it is that all kinds of highly detailed experiences come in. you don't store the micro states of all those experiences, you compress them, you learn the pattern, you develop a generative model of what was going on. That's what you remember. Those are the engrams that you store. They're stripped of a lot of the details on the outside. So that's kind of the algorithmic part where you infer the pattern and you store that. But then when it comes time to recall them, that's a creative act, because again, a lot of the actual initial information is gone. What you have is this generative seed, and so now you have to reinflate it and say, what does it mean for me now? And just as the butterfly reinterprets that information in a way that's suitable for itself in its new environment, with its new affordances and so on, one can think of all of us as being in that same boat and having to kind of creatively reinterpret the content of our own mind all the time. And this idea that then what's interesting about biology, and I'll just say this one last thing and then I'll stop. It's the idea that in biology, your allegiance is not to the fidelity of the information, unlike in our computer science, where you really want to make sure that each layer is isolated from the layers below. When you're coding, you don't think that, wow, my registers are going to float off and do other things. You can depend on it. Biology is always dealing with an unreliable medium. All right, as if you're a life form, and evolution knows that everything is going to change, not only the environment, but your proteins are going to degrade. You're going to be mutated. You don't really know how many copies of any molecule you're going to have. There's a lot of noise. There's a lot of change. You have to commit not to the fidelity of the information, but more like to its saliency. Right, you're ready to creatively confabulate a new story based on whatever you have. And so the same thing, in this paper, I talk about development and evolution being part of that bow tie too. The past and the experiences that your lineage has had in the past have created a genome and some other stuff that you have, but you're under no obligation to interpret them in the same way that your ancestors did. And in fact, you can't, because for a fact everything is going to change over time. The environment, you're going to be mutated. And this is why, one of the things we study is the incredible plasticity of life. The fact that we can take living things and, I can put we can put an eye on the tail of a tadpole instead of in their head. And those animals can see perfectly well, and they learn visual cues, even though that eye is now connected not to the brain but to the spinal cord. This radical restructuring of the central nervous system, no problem. You don't need rounds of selection and mutation. Out of the box it works. And we've done a million things like that, where I think that the reason it works is because it was never hardwired in the first place. You could never assume, coming into the world as a living being, you could never assume that things were, maybe there's a few species that do that, nematodes maybe, but most creatures have this creative problem solving, where the step one is to figure out what affordances do I have, and how do I put myself together into some kind of coherent organism and survive and do other interesting things. And this is why we can have xenobots and anthrobots and things that have never existed on Earth before, but have novel coherent behaviors and morphologies and so on. So that's the bow tie thing. It's this idea that information gets squeezed down like a variational autoencoder. It gets squeezed down into this like very sparse representation, and then there's a creative act of sense making on the other end to say, what do my memories actually mean, and what can I do with them now? That's the bow tie story.
Jordan?
Okay, so let's see. What I noticed is, yeah, I think this is actually going to be, this is pretty clean. The set of possible conversations that we can have that would be very interesting, and in fact, interesting to me, I think interesting to you and to Karen and anybody watching, is quite large. We could zoom in on that particular question and talk, for example, about the notion of perception as also a bow tie, and how perception, world building, how those things, we just kind of go off all over the place. Like, you have a lot of fun. So what I ended up asking myself as I was listening, and I've been doing this now for a while, I think I first came across your stuff maybe about 1.5 years ago, which implies either I'm slow on the uptake or something happened that enabled that connection to be made. And I've since discovered that you've had conversations with friends like John Vervaeke and Greg Enriquez, and probably many others that I'm not even aware of. And I guess when Karen suggested that our conversation could be fruitful, I was trying to figure out what's the best conversation we could have. And what I noticed was that the way I was trying to think about that had this really interesting reflexivity to it, which was I noticed 3 points that were coming up as I was listening to you that seemed, okay, these all have a certain conservation. One is the notion of mind space, or the notion of mind as having an embodiment, right? But mind as having a certain, how would you say it, identity to it, which to me began to look like a certain level of discreteness, meaning that you could have a snap from one embodiment, which was able to be affordant to one quality or singularity of mind, that there would be a traverse, and across that traverse, you could actually snap to another embodiment. So say, for example, the upper Paleolithic transition is, for example, a particular quality of embodiment in hominids that hit a different kind of mind that had a completely different set of affordances. And that the question that kept coming up for me, which felt like they were a really nice overlap, was the question of what would it look like to put together an engineering program or an experimental program orienting towards the question of what would be the form of embodiment in collective intelligence that includes human beings as at least one primary element at ontological level 1, that would give rise to a collective intelligence at ontological level 2, that would snap to a qualitatively novel level of mind. So that was a question that I've had a substantial amount of time inquiring over. In fact, I think John and I, Vervaeke and I think it was one of our first conversations was on exactly that point. And this notion that I found in your work of a strong orientation towards experimentation in the direction of what could actually then deliver on an engineering deliverable, mind space and embodiment, I thought, that might be interesting. And then what was happening just now as I was inquiring into it, I was like, what would happen if I began to self-referentially and try to embody a part of a collective intelligence, including the three of us, in such a fashion that we were actually leveraging that qualitatively distinct mind to inform the conversation we're having to get us there. Sorry, that last part is a bit of a artistic flourish, but perhaps that makes sense.
Yeah.
Did it make any sense, that last part?
Yeah. Very, very, very interesting. So do you? I'd love to hear your thoughts on that. I mean, what do you think is both kind of the role of technology in that sort of project, and what do you think is possible now? What has been done? How do you see that space?
So I'll maybe some of the space of where we've been before. So far as I can tell, there's broadly 3 strong embodiments that have kind of been able to hold together coherently over a diverse variety of contexts. The one that's the baseline is just sort of the human indigenous group. So we are obligate collective intelligence, that we form naturally collective intelligences as just human groups. And we can see this show up in, for example, the way that a group of sports, like a team of sports people will come together and they will produce something which clearly has a quality of intelligence that is different than just 5 or 12 people showing up randomly. Same thing in the military, music, that kind of thing. And all of that grounds back to something that I would just call the indigenous mode of collective intelligence, which has a certain level of capabilities and a certain level of constraints. One of the biggest constraints is that it is quite limited in its ability to scale people. There's just a certain limit on the number of people that can participate in that quality of collective intelligence before it begins to break down. And there's a bunch of breakdown elements that show up in that mode, which if we want to, we can diagnostically look at why that happens. And then we had a forking event historically where that scaling limitation gave rise to a possibility of 2 novel forms of collective intelligence that scale vastly more effectively. One is bureaucracies, and the other, which are institutional, governed by institutional forms that enable a very large number of people to participate, governed by institutional structures. And that allows the advantage of a large number of people, and it produces a form of collective intelligence that has certain capabilities that are substantially larger than indigenous groups, but actually other capabilities that are substantially weaker, and has, as far as we can tell, has an asymptotic level. At a certain level of scale, it just doesn't get any more effective. In fact, tends to get less effective. And then markets. So markets have this capability of scaling arbitrarily, as far as we can tell, but of course quite narrow in the set of things that they can actually process, both in terms of the complexity that they can navigate in one particular step and the depth that they can navigate. So those are sort of 3 examples that have shown up thus far. And I would say one story of history would say that we can even divide history into roughly three major eras. One would be the anthropological era preceding the Upper Paleolithic click, where something happened in the indigenous mode that gave rise to a qualitatively new level of intelligence, which then, of course, exploded the diaspora of humanity, Homo sapiens, across the world. And then another click that happened somewhere around that magic number of civilization, buildings, agriculture, that was deeply characterized by a shift of the majority of work. Well, maybe that's not true, but a substantial amount of the work into these other two modes would have been operating more or less at the same time together in a complex way. And so that's the background. And we can, of course, unlock any of those. There's a lot of good stuff to be had there. And a hypothesis would be something like, we're in a very interesting moment now, which shows up all over the place. Like we can do this with Kuhn and paradigm. And we now are aware of the notion of paradigm shifts in science. Because we're aware of them, the nature of what paradigm shifts look like now can't help but have a reflexivity shift. They're going to be different in nature. Same thing in terms of this form of collective intelligence, with this really weird moment where the resources or the technological substrate that might give rise to a novel form seem to be even super saturated in the local environment, but it may in fact require that we do something different, something maybe at the level of more conscious or more design or something. It's not quite clear exactly what that is, precisely because we're aware of it. So we are operating at a level where we're consciously participating in something which, as far as I can tell, has not been the case in the past. Yeah, I could go on arbitrarily, but I think that's a pretty good time to stop.
Did you want to say anything, Mike?
Well, yeah, I mean, the only thing that comes to mind right now is that the market, you know, what you said about markets. And so there have been a few people, Ben Lyons in particular, is someone who's been pointing out this. So he and I are actually writing a paper on the price system as a kind of cognitive glue. And this idea, I mean, I know nothing about economics, so this is, you know, that part's all him. But just the idea that a lot of these things can be mapped. You know, there are a lot of concepts in the field of collective intelligence and diverse intelligence that can be used to understand this kind of stuff. And I've had other people contact me who are working on this market mind hypothesis. You know. And just the idea that the economy again can be looked at with tools that we have to for interacting with other kinds of intelligences. So yeah, I think it's very interesting, and just in general, I think it's an important research direction for humanity in general is to develop tools to identify, detect, and communicate with all kinds of intelligences in very unconventional embodiments that we are not good at noticing, and in fact that we have all kinds of biases and prejudices against even entertaining the notion that you know, that these things are kinds of minds. And yeah, you know, ecosystems and economies and power grids and all sorts of, I mean, whenever we look, I mean, we've looked at gene regulatory networks, we've looked at pathways, we've looked at simple sorting algorithms. When you look using the right tools, you often find some very surprising things in this area. And I think developing those kinds of tools so that instead of guessing or having sort of, you know, philosophical feelings about it, we can actually do experiments and say, look, here are a set of tools from behavioral science, from diverse intelligence research that actually gives you a better purchase on having a mutually beneficial and enriching relationship with this system that is not you know, available if you assume that it's a basic kind of you know, mindless machine, basically.
I would definitely put some chips down.
I was going to pop in here for a second. So interestingly enough, Benjamin Lyons got in touch with me last week, Michael.
Okay.
I don't know why. I hadn't contacted him. Just out of the blue, he contacted me and he said, I'd like to talk to you. So I'm setting up a conversation with him for next week. But I think the crossover is on this issue of obviously markets, but also the idea of distributed cognition and how that relates to price. And somehow in my mind right now, that's tying me back to the comment you made earlier about in the development, the allegiance is not to the fidelity of the information, because biology is an unreliable medium, but rather the fidelity is to its salience. And that ties in with John Vervaeke's concept of relevance realization. And when John's talking about relevance realization, he's usually talking about distributed cognition as well. So because I've been listening to you for so many years, Mike, when I see things, I typically see them in terms of how the cells are operating. So now the picture I have is of these cells operating, and then spring that over into another arena and being able to see the larger thing. So I think it translates so beautifully to the whole social arena, and how these different groups of, I think that Jordan was talking about how the scaling limitations give rise to bureaucracies and markets. So I'm just throwing that in there to see if it brings a thread for anybody.
What does Ben do?
He's an economist.
Okay, so
and he had a conversation with Michael where well, it wasn't a conversation. He presented
he gave a talk at our center,
on price being the cognitive glue in the markets, I think is the way he was putting it, right? And thinking about how in some way price may be a cognitive glue in the biological development as well, which I kind of like that idea. So I had two people on my channel talking about that idea, and I think he might have seen that video. So have you talked yet about the cognitive glue idea, Michael? I mean, maybe you want to just nail that down, and then that would give Jordan a definition to work with.
Yeah, all I mean is by that is a set of policies and mechanisms that allow competent subunits to form together into some kind of an emergent collective that's more than the sum of its parts specifically. So here's a simple example. If you have a rat and you train him to press a lever and get a reward, there's no individual cell in that rat that has both experiences. So no individual cell interacted with the lever because those were the cells at the feet, and the cells in the gut got the sugar reward. But so who owns the associative memory? It's not any individual cell, it's the rat. So what's the, what holds together the rat in a way that enables it to have these memories and goals and so on that don't belong to any of its parts? Well, the conventional story is that it's the neural bioelectricity. It's the nervous system and the activity of the nerves that that allow there to be a rat as distinct from a pile of neurons. And so there are certain policies by which these neurons interact. So they activate or inhibit each other. And there's a million other things going on. And in that case, that's what's going on. We've studied other kinds of cognitive glue. For example, when you have a collection of cells, what allows them to come into alignment and work towards something very complex in a different space, like forming an organ. So individual cells don't know what a finger is or how many fingers you're supposed to have, but the group of cells that are building it absolutely does. And you know this because in animals like salamanders, when you try to deviate them from that goal by, let's say, cutting off some fingers, they bite off each other's legs all the time. The cells will immediately spring into action and get right and build it again, and then they stop. So that's the kind of homeostatic set point that they try to maintain. But that's a set point in an anatomical space that's not available to individual cells. It's only available to the collective. And so then now we have to ask, what is the cognitive glue? What are these cells doing that allows them to join together into a higher order being that can see into this other space, right? That can see into this anatomical space. And so we study things like memory anonymization through gap junctions and stress sharing and some other things that we study as cognitive glue. But it doesn't have to be that, and it doesn't have to be bioelectrics. I'm sure there are many other modalities. And I think that's very interesting, right? Is to ask what other kinds of policies are good for creating these higher order beings that can see into other spaces versus just a pile of parts.
Yeah. I mean, the generalized question of what are the characteristics of a cognitive glue mechanism independent would be like a profound tool if I'm trying to enter into the design space of taking some multiplicity and producing some identity out of it. It'd be useful to have a general theory of, okay, what kinds of things are necessary to produce the right kind of cognitive glue.
Yeah.
It's interesting because my mind starts moving in the direction of thinking about it in terms of information, but I'm not sure if even that's the right category. Think about.
Yeah, I mean, I'll I can give you one as like a simple example of the stress sharing. So just imagine, and there's a million ways this can play out, but just for visualization, there's a group of cells, and there's a cell over here, and it needs to go over there. Okay, so there's a gradient, and it's there's some level of stress that it has that will be minimized once it gets to where it's going. So the other cells are happy where they are. Their plasticity is low. The temperature of the whole system is low. They've settled. That's it. And therefore they're not motivated to get out of the way or to help that cell achieve what it needs to do. One simple thing you can do if you wanted to have a kind of cognitive glue where the whole system would be motivated to make sure that everybody's in the right place is to simply let the stress be leaky. So if the cell out here that's stressed out, all it has to do is release some of those stress molecules. In this case, like literally molecules that serve as signals of how systemic level stress. And the cells around it, now they're stressed out. And it's not that they're altruistic. It's just that their plasticity goes up, where they start to move around and to be a little more willing to do new things. Then the cell gets to where it's going, then everybody's stress drops. So what it in effect does is it means that my problems become your problem to some extent, and that you may not have a special mechanism for any kind of altruism, but just by virtue of your own stress reduction, if I'm a little leaky, then that process is going to make everybody help out. And so we've done computational models of this recently, and there's a nice paper that my student Lakshman Shrisha published, and it just shows that kind of a system without any special kind of altruism mechanism causes apparent alignment of everybody. Everybody kind of has the same goals, and so that's one way of doing it. Another way of doing it is this memory anonymization business. So imagine you have two cells, and cell A sends a signal, like some kind of let's say a diffusing chemical over, and it hits cell B. It's very easy for cell B to know that this came from outside. And as long as that's how they communicate, it's very easy for them to maintain different memories of events and different goals and so on. So they're two distinct individuals. But there's this structure in biology called the gap junction, which basically allows two cells to directly link their internal milieus together. And then something very different happens when let's say cell A gets poked by something, and there's a calcium, but let's say a calcium spike, and that's a trace of an indicator that in the past it got injured. Okay, so that calcium spike propagates through the gap junctions to cell B. As far as cell B is concerned, that's kind of a false memory because cell B never got poked, but that calcium spike doesn't have any metadata on it about who it belongs to. And the fact that they are now connected in this way means that it's very difficult for them to maintain different world pictures, different memories. They become, there's a little bit of a mind meld that happens, and the memories are anonymized to the point where it's not whether A or B has it, it's that the new system AB has this information. And now you get all kinds of interesting capabilities out of that, because if I got poked over here, well, the collective wants to know about that, because there are other things you could do from the other side that might be relevant. Right. So your cognitive light cone it scales up both in space and time, because it takes time for signals to propagate. So now you have a kind of a thickness of the now moment. So that spreading of memories that are not limited to one subunit tends to, and there's a ton of more work to be done on this. I mean, it's not enough to just give every piece of information to everything. I mean, that doesn't work either. You have to have some very clever ways that information gets around. But that idea that it's not your memories and my memories, it is now our memory in an important way. That really functions as a kind of cognitive glue that binds us together to a similar model of the world, thus to align behaviors and so on.
Do you have the language of OODA loop from strategy theory?
I don't know that. Please tell me about that.
It's really very simple. It'll make total sense. But what I'm interested in is the fact that it comes from a very different domain. So this literally comes from strategy, specifically military strategy.
Okay.
So it's by hypothesis an abstraction on strategy, which is generalizable: observe, orient, decide, act. Right. So a loop. So a given strategic actor, initially, by the way, a fighter pilot, is ultimately defined by the bandwidth they can move through that loop. And generically across multiple different contexts, if I can be inside your OODA loop, that means that I have the strategic advantage over you. Ultimately, what that means is that I actually become a cause inside your own OODA loop. You are now reacting to me as opposed to the other way around. And basically, if you can get to that location, then for the most part, in any other strategic context, you will ultimately have a strategic advantage. And as it turns out, this scales, meaning that the Marine Corps has adopted this as a methodology. So not just fighter pilots, but entire groups of entities, and they actually think about it in terms of what's the OODA loop of the entire of an organization, and what does it look like to design things that have that kind of an OODA loop, and what does it look like? What are the design characteristics that will increase the OODA loop? So, for example, during the global war on terror, what we discovered was that our special operations groups OODA loop was meaningfully slower than the distributed intelligence embodied in the terror networks. And this was quite practical. Like by the time that we had discovered, perceived, right, or observed that a particular terror network was coalescing and act in a particular location, and had gone through the process of observing, orienting on it, deciding what we were going to do, and then acting on it, they had already executed on what they were going to do or gone. So, literally, we were in a game of whack-a-mole that we couldn't catch up on. And so this necessitated a conscious movement to a different level of operations, which was at the level of learning, meaning the Joint Special Operations Command had to say, hey, we need to actually go through a process of becoming a different kind of collective intelligence that has a categorically superior capacity to develop a faster, tighter OODA loop, which they did, by the way. And then I was thinking about this. So then the metaphor I was going to use is something like an OODA loop envelope. So I'm seeing this in the sense of almost like, what's the right way of describing it? Like a standing wave, where, because I think you had 3 different discrete elements at a minimum. One was something happening at the physical level of the frame that we're operating at. So here you were speaking, it was effectively molecular biology vis-a-vis cells, what you were calling the gap junction, which opens up an affordance of a new form of perception. In this case, the experience of the calcium actually creates a memory engram at the level of a we, right? It's a new form of perception, particularly for this guy over here. And in principle, at least, enables the activation of the exploration, the new possibility landscape of agency of the we. And so you have a new affordance for perception and a new affordance for agency, which then is to say we've defined an OODA loop envelope, if that makes any sense. Which I'm saying is that there's something about this new path that's available that is available as a we, which begins to create a reinforcement mechanism around the union or the binding of the we. And so the cognitive glue has a way of developing itself over time, including both the front and the back end of that process.
Yeah, that's really interesting. I hadn't heard of that before. I wonder, I need to think through what the relationship is between the size of that loop and something that we track, which is the cognitive light cone being just the size of the largest goal that a system can pursue. So in space and time, right? What is the radius of the biggest thing you could possibly care about? And you can think of what that looks like for a bacterium, for example, is really only concerned at a very small spatial extent of whatever the local, chemical concentrations are, and it has a little bit of a memory going back and maybe a little bit of predictive capacity going forward, but that's it. So it's got a pretty small cognitive light cone. And then you get something like a dog, which has a bigger spatial extent that it's interested in. It has a bigger temporal extent. Never going to care what happens 3 months from now. 2 towns over. That's outside the cognitive light cone. But it has a defined set. And then you can think about a human, right? And in humans, I think that's actually one of these kind of phase transitions, is when your cognitive light cone gets bigger than your own lifespan. And you realize that actually guaranteed you have some goals that are not going to be accomplished in your own lifetime, right? And which is not the case for most animals. And so That no doubt leads to all kinds of interesting psychological pressures and whatnot. But then you can, well, like one thing I think about, and I have some colleagues who kind of think about the Buddhist tradition a lot, and we think about this idea of like what does it mean to commit to enlarging your cognitive light cone, in particular with respect to this notion of compassion, right? Like how, in a standard human has only so much ability to care about in the linear range to care about some set of beings, and if it's more than that, you're not twice as sad or 10 times as sad. You're just kind of, this is all you can really handle. But what would it mean, whether biologically, technologically, or in some other way, to expand that to the point where you literally can care about, as for example the Buddhists say, all of the sentient life forms and that kind of thing. So yeah, so I wonder, I wonder how the size of that loop that you just described intersects with the size of the goals that a given entity is capable of working towards.
Yeah, the two concepts fit together quite nicely. I've very much liked the consequences of your definition of cognitive light cone by precisely the degree to which agency is included. Obviously, I've had conversations with a number of people who I think have been influenced at the kind of a more Eastern tradition. And I said, well, in principle, I can invoke in myself a feeling that I can call compassion for every quantum state in the universe. But in practice, that's actually not even really a thing. Yeah. And so we have to have a concept that includes that whole set as bound together as a single unit. Otherwise, we're just we're virtue signaling to ourselves, right? We're actually trading salience for relevance. Yep. And so, are you familiar with the concept of hyperobject?
Tell me more. I mean, the geometry or something else?
No. It's the basic idea is it's a system, usually a complex system, where the amount of complexity is strictly outside of the cybernetic capacity of a cognitive light cone. So, I'm gluing some new words together, but it makes it a more compact definition. Typically speaking, well, let me just finish the definition and go back to the typically speaking. So, for example, in the context of a dog, something like traffic patterns is a hyperobject. Traffic patterns are just outside of the cognitive light cone of a dog, and so a dog may be impacted by traffic patterns. They may get hit by a car, but their ability to relate to it in any cybernetic way is zero. And the term was coined in relationship to the set of objects that are now happening to the species Homo sapiens in relationship to the maximum amount of control capacity in our current level of collective intelligence. So it was discovered that things like climate change are hyperobjects, that they are strictly outside of our cognitive light cone. They live within the zone of our kind of our compassion zone. We can be aware, like dogs, we can be aware of them, and we can yearn to want to deal with them properly, but we in fact cannot currently interact with them inside our cognitive light cone as defined. And there's about maybe 12 or 13 of these that have sort of been identified, and they're mutually implicated. So it's better to think of them as a single giant hyperobject, but each one can also be perceived as such, and that's helpful sometimes. And this gives rise to why the original question was what I was focused on, meaning there's a sort of a clear and present reality that we're in this unusual circumstance that the consequence of the previous stage of our collective intelligence is output through its agency a new level of complexity in our lived environment that it can't deal with, but that we must deal with, and relatively soon. And we can go on, but for example, one of the things that you'll notice is when we try to interact with something which is outside of our cognitive light cone, the consequences of our agency is at best random, and more often actually produces a variety of secondary and tertiary consequences that make the situation worse. And so a big set of the explanations for why things have been happening geopolitically, but at the level of society and culture over the last 80 or so years, a lot of what's happening is a leakage of agency on events that are outside of our cognitive light cone using the best capacities we have. And that obviously creates a weird terminal event.
So, Mike, I don't want to destroy your thread of whatever you're thinking right now, but I did want to ask you, do you think that this idea of the hyperobject might relate to how an individual cell relates to the whole of the body, because the body itself would be outside the cognitive light cone of the cell.
Yeah, yeah. I mean, it happens even below the cell level. So below the cell level, you have molecular networks that also have learning capacity and you know, several other things that will be coming out of our lab soon. And then you've got cells and tissues and organs and so on. I mean, this is all over the place. And we've had interesting discussions internally about what would it take, for example, for a subsystem to gain evidence that it was part of a larger system, right? So, I mean, I think we build these things all the time. We build social, financial structures, we build Internet of Things, we do all these, and we have pretty much no ability to know what kind of intelligence we're creating, what will be its competencies, what will be its goals. You know, and I think it's really important for us to develop a science of that, like critically important. And so, you know, we were like, I don't know that you can ever know what you're part of. There's probably some sort of Gödel style, you know, version that basically you can't ever know for sure. But I bet you could gain evidence for it, you know. And I think, you know, I was trying to visualize what would that look like, and I was visualizing, you know, kind of two neurons in the brain talking to each other, and one is kind of a you know, kind of a materialist reductionist, and one is a little bit more mystical. And the one says, you know, I sometimes feel like we're part of this greater thing, and there's something going on here. And the other one says, "Nah, you're crazy. It's all you know, chemistry, and our universe doesn't care about us. There's nothing else going on. There's no purpose. There's no. It's a mindless cosmos that we live in." And the other one says, "Yeah, but you know, there are these like depolarization waves that come through, and I almost feel like we're being, you know, trained or something. Like it wants something. You know, there is mind out there somewhere." And so, yeah, I don't think you can prove it, but I wonder if what it would feel like, I think, is synchronicity. You know, that if you drill down to the physical causality, you don't find anything, and it just looks like random stuff that happens. But if you take a step back and look at the broader patterns, and you have to be a mind yourself for this, you know, you have to have the capacity to recognize these things, or you'll never, you know, you'll never see it. But you look back and you say, wow, at this higher level, there is something going on. And the other way, kind of, there's a more mundane kind of version of this too that I was thinking about recently, which is, you know, from the if you drill down inside so you've got a computer and it's running, I don't know, Microsoft Excel or something, and it's calculating some stuff, and you drill down, and the one transistor that's somewhere in there, what does it see? Well, all it ever sees is the laws of physics. Like yes, the electrons do what they do, and it's Maxwell's equations and whatever, they're just doing what they do. But isn't it amazing that at the same time, this whole thing is executing this crazy mystical thing called an algorithm? You know, what algorithm? How is there going to be, you know, there's no magic down here. The physics are determined. It's just going to do what it does. And yet there's this other level, this ineffable algorithm that in some way makes the electrons dance. And thinking about that level is profoundly important, not just to understand what's going on, but more importantly, to make new stuff. You know, to do the next thing. If you think it's all the laws of physics, you're never going to code anything new. You know, you're not exactly wrong if you reverse engineer something that someone else had done, but you're never going to code anything new like that. So yeah, so I feel like, you know, that may be what it would. That's the closest concept I think we have, is something that feels to us like synchronicity. That there's a larger pattern here that is not going to be derivable from the lowest levels that we observe.
Another pattern that seems to show up is a significant decrease in effort with an increase in effectiveness. Yeah. So these happen, for example, in the context of, say, dancing, like two dancers who are learning how to dance together. When something has happened where they're actually dancing together, they both perceive and report a significant decrease in the amount of effort necessary to dance. And there's a transition, right? There's an actual process of practice, and then something like entrainment or harmonization, which is very subtle, right? You can't actually ever enumerate the total set of things that are associated with that. It's an extremely complex phenomenon, but it's something that, one, you can get better at, and two, everybody goes through it when they do it. And when you get to that critical point, something occurs where there's actually now an identity, and that identity is larger than the two individuals and is doing something that radically reduces their perception of effort, and to outside observers increases the quality of what they're doing together.
Yeah.
Same happens with, say, again, like a jazz band, a sports team, any collaborative group actually. Every collaborative group notices that there is some kind of protocol of relationality that produces this experience of coming together into something like an identity that has a double whammy of decreasing the amount of effort that each individual experiences and increases the effectiveness of the group. So I think you would see that as well.
Yeah, that's super interesting. I mean, quantifying or at least characterizing effort, I think is really important. And how we've been thinking about is in the case of some of the biomedical interventions that we try to develop. We have these let's say we develop this thing where you can induce a particular bioelectrical state that then causes an ectopic eye to grow, a whole eye or a limb or something else. And then people say, well, sure, but downstream it's just turning genes on and off, so ultimately that's really what it is. So why don't you just sort of skip all the stuff on top and get right down to the to the molecules. And there, if you quantify effort, you see it immediately, because if I were to try to micromanage 10,000 genes as a function of time, I mean, maybe that could be possible in someday, maybe, but you spend much less effort by communicating with the system at a higher level to give signals that say build an eye here that then propagate down, and you're not there trying to 3D print everything and put all the cells where they go and all that stuff. So I completely agree with you that if you track the amount of effort that it takes to make something happen, you can find levels of optimal levels of being that are not equivalent, and certainly not. I mean, Dennis Noble talks about no privileged level of causation, right? So in different systems, sometimes it is the lowest level that does all the work, but usually, at least in biology, usually not.
That's great. Yeah, that's really nice, because you can quantify it and you notice the difference. Yeah. And that's from another thing that we can notice in our contemporary, at the socioeconomic level. I think literally everybody tends to notice this anthropologically, and that is the amount of burden, cognitive burden on individual members of our society is going up. Right? Yeah. So we're actually more and more, and we can also look at it institutionally. Like, why are many of our institutions breaking down? One of the reasons why they're breaking down is the amount of effort that needs to go through that institution has increased continuously over the past 50 years or so. Somewhere since the late 70s, it began to accelerate. And there's that has this really interesting math to it. There's ultimately one of two possibilities at the end state of that. Either those systems are going to begin to break down inelegantly, i.e. they're not going to be able to continue to handle that amount of increase, or there needs to be the emergence of some new level that has this effect of radically decreasing the amount of burden on one level and increasing its local effectiveness by being able to operate at a level that just has a completely different relationship with effort.
Yeah.
So one of the things that I talked a lot with Glenn, my physicist friend, about is this idea of the inside and the outside, that there's a nesting that takes place at these various levels. So if you take, for example, a watch, the inside of a watch is filled with all sorts of complicated things, but then the outside of the watch is much more easily manipulated by the owner of the watch. They just turn it on and they look at it and they can read the time. But then you think of that owner now as now the inside. And they're pretty complicated until you get up to the next level, and then you have maybe societal controls or something like that. But if I think of this in terms of these patterns that you're talking about, let's say, for example, dance. The inside of dance is learning all the rules and all the skills and everything that it takes to become an effective dancer. And there's a lot of effort there. But once you get to the outside, where now you have integrated all that effort, so now it becomes effortless for you as a couple. But let's say now that couple is part of a larger group of dancers that have to put their patterns together as a group. They're going to have to learn a new set of rules that's very complicated and difficult, but then you get to the outside of that and it's effortless. So I'm wondering if there isn't something like that happening at all these scales with cells and
yeah. Yeah, I totally think there is, because you know, I think what happened, I mean, okay, imagine that you wanted to train a rat to do a circus trick of some sort, right? You wanted the rat to do this complicated thing. One way you could do it is to try to run it like a puppet, and so figure out every muscle motion that it has to do, and then trace the neurons back, and then those through the brain, and all the, and then eventually, you know, get to what stimuli you need to give it, or what you could do that. That would take, you know, probably the sun would burn out before you actually, you know, you will figure out all those things. Or you can just train the rat. And the reason is that it gives you this amazing learning interface that abstracts all of that. It does all the hard work of taking what you want and encoding it into the internal microstates that make it happen. You don't need to worry about any of that. You're not searching the space of neuronal activations. You're searching a much easier space of behavior shaping cues. And right. And so I think in biology, there are two opposing forces. One is you want that kind of encapsulation in all the layers, because you want the system to be easily controllable to itself. So you want to run your own parts that way, right? And so that abstraction and encapsulation and modularity, you want that. The thing I think that limits that probably is if you're too understandable, you're too easily hacked. And so if these interfaces are powerful and easy to use and so on, some parasite, cheater, exploiter, whatever is gonna now be hacking you all the time. And so I think those two things kind of go back and forth. But overall, I definitely think that there's a you know, in these kinds of systems, the complexity, when they're simple, they're easily managed. Then they get complex, and there's this like uncanny valley when they're very complicated and they're really hard to deal with. But then if you push through that, you get systems that are cognitive systems that offer this kind of learning, communication, and whatever, where now it's much easier again, you know, and figuring out where, you know, can you find that point, and can you find what is the high level interface that I can use that isn't the micromanagement one. And I think biology definitely does that. I think it makes these easier interfaces specifically so that the system can use them itself, but then you get to use it too as a, you know, as an external interactor.
I just want to throw in really quickly, I think that's the crossover with Benjamin Lyon's looking at markets through the Austrian economic lens, is that the Keynesians and Galbraithians and all those guys, they analyze the markets down to the finest detail. But the Austrian economists, they analyze human action. It's two different entire levels. It's like you're talking about with the rat. And I think that's maybe the thing with the OODA loop too, because the OODA loop, the reason that we were going slower than those, was it Taliban or Hamas? Who was it with? It was going fast.
A whole bunch of different groups, but let's just go with
because they had the distributed cognition going, just like in the market, just like with the price mechanism in the market, that just it propagates on its own because of all the human action involved, and it propagates so much faster than what you can analyze it, than what you can break it down. I don't know if I'm making sense, but
well, let me say, sort of restate that last part. So what was ultimately happening was that you had a competition between a form of collective intelligence that was more fully leveraging the signal propagation dynamics of the market, and a form of collective intelligence for a variety of reasons that was ultimately gated by the signal propagation capabilities of a bureaucracy. And so what happened was there's things that you can evolve, or how do you say, you can design novel capacities in either substrate. You can think of, like, say, for example, I don't know, something like eBay or Uber are mechanisms that are able to play with the market meshwork element, and then construct something on top of that, that structure that and use that in a certain way. So they're blending these two functions together. So, you know, let's say our team, JSOC, was sitting with a particular bureaucratic fundamental and had to substantially increase the more meshwork. The technique is called network of networks. So they had to innovate a much more networked methodology because the adversary was already using a much more networked methodology. And it turns out that a properly structured network has certain capabilities in terms of velocity of action and actual bandwidth of propagation of perception that more vertically oriented World War II style bureaucracies just can't do. It doesn't have the same level of concentrated energy delivery. Right? They can't build nuclear weapons or deliver them, but that wasn't the nature of that conflict.
I think this is why poetry teaches people more than long lectures. Because the poetry opens you up to this space where the tumblers sort of fall into place on their own without having to think it through piece by piece. So
can I say back to you a different way? Because I'm interested in if this unlocks anything. So the way I've long thought of it is that it's because poetry is actually more fundamental. Every form of prose is actually a form of narrow poetry. But not every form of poetry is a form of prose. So it's basically when you're communicating in poetry, what you're doing is you're communicating at a more fundamental substrate. And so you're learning the more fundamental substrate, and that carries a substantially different quality. Prose is a subset of poetry that has very specific capabilities. It's more sort of narrow and vertical. It's quite good for organizing cookbooks and planning trips to Disneyland, but that's what it's good for. And it's not anywhere near as good as say conveying meaning.
So Mike, I know you have to go in 2 or 3 minutes. Is there any way that you think of the movement of your cells as being poetry?
Yeah, sure. I mean, well, I know nothing about poetry, but I'll just say two things that come to mind. One is that in that Bowtie's paper, I talked about different kinds of writing, scientific papers, language, poetry in particular, as the middle of that bow tie. This incredibly compressed thing that you will then have to creatively uncompress and apply in your own mind to whatever meaning it has to you, and it will be on you to sort of pull the details out of it that are not there in a linear way, the way that you just said, with a cookbook, where the fidelity there really is to the specifics of the information. If I say, this many cups of whatever, it really has to be that, versus in a deeper compression, you get some sort of an aphorism even, or a deep truth encoded in a really tight kind of a message that you will then have to unpack, and you may unpack in all kinds of interesting ways. And the other thing about poetry and art in general is that if we think about what Chalmers called the hard problem of consciousness, why is it different than all the other science that we do? Part of the issue is, if you think about what should the output be, if you had a correct theory of consciousness, what would it output? Because if it outputs facts about brain states and functional activity, well, that's behavior and physiology. That isn't consciousness. So we already have those things. So what is it that it should output? And one thing that it can output is protocols for putting you in the same conscious state, or at least as close as you're ever going to get to something else. And now right? So if that were to be possible, so one could imagine that the output of a proper of a good theory of consciousness is poetry, it is art, so that when it's not a story about your neurons or whatever, it's literally a protocol for you to experience some of that state. And now you've gotten something out of that through the theory of consciousness, because now, wow, okay. And I think it was maybe Lewis Carroll or somebody who said that if you want to explain fear, don't write about fear, just tell them something that'll make them scared. And that's the idea, right? Is that you're using a protocol to transfer your state to them. You're not going around in this kind of a third person description.
That's terrific. Well, I want to honor your time, Mike, and I want to thank both of you so much for joining me. And if you decide you want to get together again, let me know, or get together on your own. I know, Mike, you have your academic channel, which is, I wish you'd open up the comments on there, because it springs so many ideas to mind. I just want to write.
Yeah. No, unfortunately, I've seen I don't have the wherewithal to monitor that stuff at all.
I know it degenerates.
I can't deal with what will come on there.
Yeah, but I do want to point everybody towards your academic channel, because the stuff that's going on there is just amazing.
Oh, thank you so much. Actually on the blog, the comments are open on the blog, and weirdly enough, that it's thoughtforms.life. And those comments have been very high level. There's actually, I've gotten tons of use, just personally, selfishly, I've gotten tons of use out of it, because people put up all like really good ideas and thoughts and so on. So that actually worked well.
I'll put all that in the description section, and thank you guys.
Thank you so much.
Talk to you soon.
Yeah, I'm sorry I have to run. Jordan, it was
Yeah.
awesome to meet you. Thank you so much. Thanks, Karen.
Bye-bye.
Bye.
Talk soon. Bye.